Okay, in chapter 9, which we have just 3 sections left total, in chapter 9, we are continuing with hypothesis testing, but now looking back at the confidence intervals that we learned in chapter 7 and seeing how those two things fit together with different types of tests. So the type of test we're learning to do in this section is a test when we have two proportions. So that means that we have two separate populations, two separate samples that we are comparing to each other, and the claim is going to be some sort of comparison. So saying either that one is bigger than the other, one is smaller than the other, that they're different from each other, or that they're the same as each other. So we're comparing two different population samples with each other. We, of course, have requirements in order to use the methods in this section. Both of our samples have to be simple random, so make sure it's a good type of sampling first. The samples have to be independent of one another, so what happens in the first sample cannot affect what happens in the second sample. And each of the samples has to have at least 5 successes and at least 5 failures. That just makes sure that we have a large enough sample size to make sure our data is accurate. So it prevents us from just having a sample where maybe we only had, one failure and we're keeping the percentage is really low when maybe that's not accurate if we make the sample bigger. So we want to have at least 5 of each to ensure accuracy on that end. So because we have 2 samples, we have a lot of new symbols. I'm sure you could probably guess what many of them stand for, but we're going to write them out here. So P sub 1 stands for the proportion know why it wasn't, I had the pink selected, but it didn't start out that way. Proportion of population 1. N sub 1 is the sample size of sample 1, which of course sample 1 should come from population 1. X sub 1 is the number of successes in sample 1. P sub 1 hat is going to be our value that we get. So it's going to be the proportion for the first sample, which means that it is going to be X sub 1 divided by N sub 1. So it's our proportion for sample 1. And Q hat sub 1 is going to be the basically failure rate, because our P sub 1 hat is kind of our success rate when we have that proportion. And we find Q1, Q sub 1 hat by doing 1 minus P sub 1 hat. Then we're also going to have P2, N2, X2, P sub 2 hat, Q sub 2 hat, all the same meanings, but for population 2 and or sample 2. Because we have 2 separate populations, 2 separate samples, this is the first time we have seen a pooled sample. So this P bar is how we read it, just like we would say X bar. So we've got a bar over the P. That means the pooled sample proportion, which is what we get when we bring them together. So we take both the successes from the samples, add them together, add the sample sizes together, and pool those. Q bar then is going to be 1 minus P bar, as you might expect. In this section, when we're doing the hypothesis test in our calculator, this is the keys that you're going to hit in order to run that. And the confidence interval also has its own set of keystrokes for the calculator. I would strongly suggest in your box that you write down the calculator steps and what type of test it is, because we've learned a lot of them, and when we do the quizzes you only have 1 or 2 that you have to know, so it's not too bad. But keep in mind that on the final exam all of these are mixed together, and it's important that you know which type of test to run. So I would strongly suggest writing out all the tests we know and when we use them, looking at your notes. Okay, so we're just going to do one example because really both hypothesis testing and confidence intervals are review. It's just that doing them for 2 populations and samples is different. So I think one example should do it. So we've got a random sample of both males and of females, and we have reported data for how many write with their left hand and how many don't. So this again gives us kind of a binomial idea. Either they write with their left hand or they do not. We would assume that most of these are right-handed, but I guess it could be people that are ambidextrous as well. So we're going to use a 0.01 significance level for both of our claims here. So in A, we're going to test the claim with a hypothesis test, and in B, we're going to test the claim with the confidence interval. And then I'm going to talk about how those relate to each other, because sometimes the understanding of it is a little bit tricky. So the first thing that we need to do for our hypothesis test is to write out our information for P1, P sub 1 hat and P sub 2 hat, and then write out all the same things that we learned in section 8.1 about the steps for hypothesis testing. So first thing we need is our P sub 1 hat, which in this case, our first sample was of the males. What was considered success would be left-handedness, so that would be 23 for our X sub 1. Then our sample size, be careful, don't just write down the other number that you see. The total sample is including left-handedness and not left-handed. So the total sample size is 217 plus 23, so we're going to write 240 here. Then we have our P sub 2 hat. So for our second sample, we had 65 females that wrote with their left hand, so that's our X sub 2. And then our N sub 2, which goes on the bottom, same thing. You have to add the 65 to the 455, which gives us 520. We know that our alpha is going to be 0.01. Okay, so our claim in this case was that the rate of left-handedness, which would be the proportion, right, of left-handedness among males, is less than the rate of left-handedness among females. So symbolic form is always what we want for the claim, and in this case that would be that P sub 1 is less than P sub 2. So null and alternative hypothesis work the same way they always have. Our null should always include an equal sign. So null is going to be that P1 and P2 are equal, and our H1 is going to be the same as our symbolic claim. Now keep in mind what this is saying. The claim is saying proportion for males left-handedness less than proportion for females left-handedness. The null hypothesis is saying that the rates are the same, that the proportions are equal, meaning that the rate of left-handedness for males and the rate of left-handedness for females is the same. So that's what the null is saying. Okay, so just like I did in the last lesson, I'm going to do both the critical value method and the p-value method. It will typically specify for you on the quiz which one you are supposed to be using. So I'm going to do the critical value method first. So find those critical values. This is a left-tailed test, so if I'm drawing the picture, that means that our area of 0.01 is on the left side. So I am using Z, these are proportions, Z test, Z interval, so that means I'm going to do inverse norm here. So inverse norm of my 0.01. Remember that when we're finding critical values, we always use the 0 and 1 here. And that tells me that my critical value is negative 2.33 when I round it to 2 decimal places. So now I'm going to run the test in my calculator because that's going to give me my test statistic. It's also going to give me my p-value. So that one I'll show you on the calculator here. So go back up here and stat, tests. And again, search for the right one. This is a 2 proportion z-test, so press 6 for that. Then I have to enter all the values that I had originally. So my x sub 1 is 23. My n sub 1, what was my n sub 1? 240. X sub 2 is 65. And n sub 2 down here was 520. Then choose the type. It's less than. P1 is less than P2 was our claim. Scroll down to calculate. Tells me what type of claim I had asked. Here's my test statistic. Here is my p-value. Notice that it also gives me in decimal form my proportions, which is kind of nice, and it also reiterates for me my other values that I had. So I'm going to write down my test statistic, which was z equals negative 1 point, let's see, what did it say again? Negative 1.17. My p-value, in this case, to 3 significant digits is 0.121. So when I'm making my decision, if I'm using the critical value, remember that since it's a left-tailed test, rejection region would be over here. This value is negative 2.33. So my test statistic would have to be less than negative 2.33 in order to reject. This is not, so I cannot reject. So this is telling me to fail to reject my null hypothesis. Then if I'm using the p-value method, remember I'm comparing the p-value to the alpha value. This p-value is not less than the alpha, which means also same conclusion, fail to reject. So since I am failing to reject the null hypothesis, we still continue with that tedious wording. My claim did not include equality, which means I'm going to use the word support. Because I failed to reject, that means that I'm going to say there is not sufficient evidence. So my final conclusion here is there is not sufficient evidence to support the claim that the rate of left-handedness among males is less than the rate of left-handedness among females. Notice that I did use some abbreviations here. I know it gets old writing everything out, but please make sure that you don't, skip actually writing out what the claim is. I don't care if you abbreviate, but please make sure that you actually write it. Don't just write, there is not sufficient evidence to support the claim. It's important that we state what the claim was. Okay. Last thing now, we are going to test the claim with a confidence interval. So remember that when we have, in this case, my alpha is 0.01, and when we have a one-tailed test, hold on, barking dog. Remember back from chapter 7 that when we have a confidence interval that we use 1 minus 2 alpha for one-tailed tests because we're trying to get the percent confidence, and we use 1 minus alpha for two-tailed. So it's kind of the opposite of what we would traditionally think. You would think two-tailed would have the 2, but it's the opposite here. So in this case, to find our confidence level, we do 1 minus 2 times 0.01, which gives us 0.98. So we are creating a 98% confidence interval here. So I go to my calculator. Remember, I'm going to choose choice B to proportion Z interval. So stat tests. It's usually easier to go up than down. So to proportion Z interval here. And notice that it automatically carried over my data from what I had done in the last test. So that's super nice. You can just double check it. Now my confidence level I do need to change. So 0.98 is what I should be using here. And then go down to calculate. So on here, I have my values, which I'm going to write. Now what goes in the middle is important, and this is going to be different because we've never used two proportions before. So I'm going to scroll this here. When I write my boundaries, so I had negative 0.0848. What goes in the middle is the difference between the two proportions. And this is always true because we're looking at what the difference between proportion 1 and proportion 2 is. Then right side boundary, 0.0, and I don't need all of these. The rule for rounding, I guess I should write that up here. Round 3 significant digits. So in this case, we don't need that last 4 that they gave us. It's just 0.0264. Now, because we have a difference here, the interpretation, it's important that you understand what it means. If I am subtracting two quantities and I get something that's negative, what that means, so I'm going to write this all out to the side, means that P1 was greater than P2. Or, no, sorry. Don't have an eraser on this thing either. Means that P1 is less than P2 if it's negative, because smaller minus bigger gives me a negative number. If P1 minus P2 is 0, that would mean that P1 and P2 are equal. If P1 minus P2 is positive, that would mean that P1 is greater than P2. So we're looking at the difference, and the way that we interpret the confidence interval is by looking at the values themselves. So I have a negative value on the left side, but I have a positive value on the right side, which means that somewhere in this interval is 0. So the typical way that we interpret this is we would say, since the confidence interval includes 0, that means that there is not a significant difference between P1 and P2, meaning they could be equal because 0 is my confidence, is in my confidence interval. Now, if both sides were negative, then our confidence interval would imply that P1 is less than P2. If both values are positive, that would lead us to conclude that P sub 1 is greater than P sub 2. So we're looking to see whether both boundaries are negative, both boundaries are positive, or if I have one of each. So in this case, because I have one of each, I'm kind of falling in this middle value here where it's possible that P1 and P2 are the same. So if there's not a significant difference, they could be the same. That means I can't, with confidence, say that they're less than. So I end up with the same conclusion, same final conclusion as my hypothesis test. Because in my hypothesis test, I said there wasn't evidence enough to say it's less than. Here, I'm saying that I can't rule out that they're the same, which means I definitely can't say that it's less than. When you are doing both the confidence interval test and the hypothesis test for the same claim, you do not need to rewrite this whole final conclusion again. Now, if you're only doing the confidence interval, then yes, you need to write this out. But if you're doing both, there's no reason to, cramp your hand by writing this entire thing twice. So you can just do like I did here, same final conclusion as the hypothesis test. All right, hopefully that makes sense. I think that should give you enough to be able to do your practice problems.